Hi, good morning, everyone. Welcome to the Zoom session for this week. You see here, we're working on chapter 6, looking at ratios and proportions this week. Get to utilize your work from the order of operations, fractions, decimals from the previous weeks. And so it's sort of all at this point starting to come together here in this week and next week. Everything you've used in the prior, 3 weeks, you get to use those to solve the new problems. And so really, kind of just looking ahead a little bit here, when we start looking at the final exam for next week, um, I know that's a common question I get is, how can I review? How can I prepare for the final exam? And my feedback typically, and what I want to share with you is you are essentially, as you do the work this week, you are essentially preparing for the final exam. You are applying your work from fractions, decimals from last week. You're applying your work from order of operations from a couple weeks ago. You're applying, when you get to next week and uh, doing some geometry stuff, you're going to be using your work on order of operations and solving equations. So even this week, proportions, you're going to be solving equations. So essentially, this week and next week really are preparing you for the final exam. So I always tell students, your time is precious, your time is limited. Um, you don't need to do anything extra to prepare for the final exam because you are effectively doing that this week. And so I think you're going to find that you're very well prepared for the final exam when it does come. So my point is, I don't mean to belabor the point, but what I'm trying to convey here is that you've come a long way. You've got a lot of skills under your belt, and you're utilizing them in not only to learn new material, but also to review the prior material for the past 2 weeks. So you're going to be well prepared for that final exam. I think you're going to find that you don't need to do anything extra. Doing the homework and the quizzes for this and next week will be sufficient. Okay. With that said, let's turn our attention to ratio and proportions here that you see on the PowerPoint slide. Now, really, what we're talking about is when we say the word ratio, we're actually talking about fractions. Uh, fractions. Okay. So, you're already well ahead of the curve in dealing with ratios, and proportions are really just fractions inside equations. Again, you've already done that too. What we're looking at, though, when we talk about ratios and we talk about proportions, what we're actually talking about is, trying to either expand or contract. Think of, let me a quick example here, and we'll talk about several more. Is think about a recipe when you make, say Thanksgiving dinner, you have maybe a green bean casserole recipe that you have, but you're going to take it for a family event, and so you need to increase the recipe so that you have enough to feed everyone. So if you want to double the recipe, you double all the ingredients. Um, and so that's the idea is you're trying to what's the ratio of ingredients that you need. How do you expand it, all that stuff. That's what we're really talking about here. So ratio and proportions are really trying to apply to the real world to take what you have and expand it out to, a given situation. And we'll talk about a couple other scenarios. Okay, so a lot of different context here. We'll talk about ratios, but we'll apply that to the notion of rates and unit cost. And unit cost, particularly in this day and age of inflation, really is the important key here. And then we talk about proportions, which is setting two ratios equal to each other. And then we'll look at some application. Okay, so what we want to do is write a ratio. Look at ratios, mixed numbers, and then applications of rates. So ratio is really just a comparison of two quantities. What's the number of boys to girls? What's the ratio of boys to girls in the class? What's the ratio of A's to B's or A's to passing or whatnot? You're just setting two quantities and comparing them to each other. So we can write ratio in a myriad of different ways here. You can actually say, A to B, boys to girls, the word two being the key there, or you can replace the word two with a colon, means the same thing, or you can write ratios as fractions. Okay, and that's oftentimes what you'll see is you'll take a ratio and you want to convert it to a fraction. So essentially, anytime you've been dealing with fractions, you've been dealing with ratios. Okay, so the ratio of women to men. Oh, yeah, I'm sorry. We want to write the ratio of women to men. So we can write it as 15 217, sure. We can write it as 15 colon 17, or we can write it as a fraction 15 over 17, women to men, either way. And one thing to take note here is notice that when you write it in a fraction form or in any way, you're really just translating left to right. So when we write this right here, 15 to 17, this is expressing that the numerator is first. It's in the top, and the denominator is written second. Okay. So women to men, 15 to 17, translate it left to right. Okay. And same thing, the fraction, top to bottom, left to right, top to bottom. So what you see left is the top of the ratio. Oops, sorry. Okay, so if we were to extend it, another example here right quick. We have a recent flight from Atlanta to San Diego. So Atlanta comes first in the ratio to San Diego second. So 291 seats were occupied and 21 were unoccupied. Write the ratio of occupied to unoccupied. So here we actually switched it up. So occupied to unoccupied. So what were occupied? 291 were occupied. So that goes first because we want occupied first. To unoccupied. Oops, 29. So write that as a ratio, or we can write that as a fraction. Okay, with the top being occupied and the other ones being unoccupied. Unoccupied. Okay, so that's how you write the ratio. Just translate it left to right and uh, um, translate it left to right. Sorry. Okay. So next what we want to do is we can do mixed numbers as well. The length of a rectangular picture. Here's a quick example. The length of a rectangular picture is 7.5 inches and the width is 6.25. Express the ratio of the length to the width. So we want, we do my typewriter here. We want the length to the width, okay? So the length is 7.5 to the width is 6.25. So how would we write seven? So what you want to do is you want to write it in whole numbers in lowest form. So what we have to do is take the 7.25 and convert it to fraction. So that's 14 over 2, or 7 1/2, which you then convert to an improper fraction of 14 over 2. Okay. And then this one, 6 1/4, well, 6.25 is 6 1/4, and then convert that mixed fraction into an improper fraction to get 25 over 4. Now remember, this means, you can translate it to colon, but we can also translate it as a fraction itself, okay? So this becomes 14 over 2 divided by 25 over 4. So essentially what you're doing is you're dividing two fractions. And remember how you did that. So you take the division symbol in the middle and convert it to a multiplication, and then you reciprocate or flip the second fraction. That's from last week's material. So really what we have here, really what we have here is the multiplication of two fractions. So come up here, 14 over 2 times 4 over 25. Now do your multiplication, simplify all that stuff. So here, so 14 over 2, it's 15 over 2. I made a mistake. I'm sorry. This should be 15 over 2. This should be 15 over 2 as well. So I'm going to scratch this out. I'm going to come over here. Let's put it in black ink now. So that's 15 over 2 times 4 over 25. So we can do some canceling here right quick. So this 2 goes into 4 2 times. 5 cancels from here, 3, and then 5. So what we get is 3 times 2 over 1 times 5. And so it gives us the fraction, 6/5. Boom, boom, boom. That's what they want. So what's the process here? We wrote our ratio length to width because that's what they wanted. What's the ratio? Length to width. Just translate it left to right. So length to width, okay? Then we inserted our values into the ratio 7.5 to 6.25. Then what they wanted was they wanted a ratio of whole numbers in lowest terms. So what that means here is that you need to convert the decimals into fractions. And in this case, they converted to improper fractions because they were mixed numbers. And then because it's a ratio, remember that's division. So we're dividing two fractions. So from here to here, you have to apply your process for dividing two fractions, which means flip the second fraction from 25 over 4 to 4 over 25 and change the division to multiplication. And that's what we did right here. Okay, and then apply your process for multiplying fractions that we did last week. So this is the sort of thing that they want here. They want a ratio of whole numbers, 6 over 5. They don't want decimals. They don't want fractions in the top and bottom, just one nice fraction. And the fraction here, by the way, you know, is the final answer is 6 over 5. The final answer can be an improper fraction and would be an improper fraction as well. Okay. Okay, so here we want to write this ratio as whole numbers expressed in lowest terms, $4.2 to $2.88. Okay, doesn't matter to the dollars, those will actually cancel. So we do the same thing. Convert this to an improper fraction, so 4.2. Remember how you do that? That's 4 and 20 over 100. Remember to convert this to a decimal. You take it to it's 20, it's well, it's actually 2/10. We can do that way. 2 is in the 10th spot. Or you could do 20 over 100 because remember, this is dollars and cents. You know, 20 cents over 100 cents. You know, that's why I did that first. 20 cents over 100 cents, that's the ratio. So this becomes what? You can simplify this fraction, 20 over 100, down to 1/5, and then convert this to an improper fraction. 5 times 4 is 20, plus 1, so that's 21 over 5. Same thing here, so 2, so then we'll do we can do a colon for the moment. Let's do 2, actually. 2. Now this one is 2. Now we have to actually do this one, 88 over 100. That's 88 hundredths. 88 cents over 100 cents. Simplify that, so that's 2. You know, cancel out a 4 from top and bottom, I guess. So that's 11 over 25. And then convert it to a mixed fraction. So 25 times 2 is 50 plus 11 is 61 over 25. So remember, this is a ratio the entire time, okay? Now what we're going to do is we're going to replace the 2 with a division symbol, okay? Divide. So what we have is a fraction divided by a fraction. Apply your process for dividing two fractions. So I'm going to come up here. So I have 21 over 5. And I change the division to a multiplication and flip this second fraction. It becomes from 61 over 25 to 25 over 61. Okay. Now multiply your fractions. And so for this one, we can cancel the 5 here with the 25. So this becomes 5 times 21 in the numerator. So 21 times 5 over 61. You just can't cancel anything. So that becomes what? 105 over 61. It's not pretty, but that's it. That's what they want. That's what they want. So convert to mixed fractions, simplify your mixed fractions, convert to an improper fraction, and divide those improper fractions, and apply your process for dividing fractions. That's the process. Okay. So applications of ratios, we've already, you know, sort of seen it. I'm going to kind of move forward here, but you can basically, they want the ratio of the increase in population to the original. So basically take the values here, 210, 210,000, to 239,000. Oh, well, hold on. No. They want you to write the ratio. Let's look at the question. So the population rose from 210,000 to 239,000. Okay. So they want to write the ratio expressing the increase in population to the original population. So we want the increase. So we want the increase to the original population. Okay. So what's the increase? Well, the increase was 210 to 239. So the increase was actually what? 29,000 to the original population of 239. That's what they want. The increase was 29,000. And so you make the ratio of the increase to the original 29,000. So now we can set it up as a ratio. So that becomes 29,000, or as a fraction, I should say, to 239,000. And we can simplify this by dropping the zeros. So this becomes 29 over 239. Okay. And does this simplify? I don't think so, because 29 is a prime number, and but try it out, see if it simplifies. I'm trying to simplify it on my fraction, and it doesn't. So this would be it right here. This would probably be as best you can get. Okay, so let me jump ahead here. Rates and unit cost. This is kind of what I wanted to get to. What is a rate is basically whenever whenever you're expressing a ratio, it's basically a rate is a ratio. It's just a ratio applied in a specific context. So you use rates and ratios all the time, miles per gallon, miles per hour when you're driving, things of that nature. So when you're looking for the key words is the word per, for, in, on, and there's a fifth one also, by the way, every. There's also a fifth one that you would see. 5 miles for every gallon, things like that, or 5 miles per gallon, things like that. So rates are basically just the rate at which it's actually it's what we call as a rate of change. How many miles can you go for every 1 gallon of gas? How many miles can you travel across 1 hour of time period? It's just a ratio and you're comparing two quantities. But in a sense, what you're doing is you're telling yourself how much something is used up or how far something goes, things of that nature. How much money do you use up when when filling up your tank of uh, in your car of gasoline, things like that. How far can you go for this tank of gas? That's really what you're expressing in all this. Or if you got an electric, how far can you go on this one charge? Things of that nature. So the buzzwords you look for: per, every, for, in, or on. And really, these are really the two most common: per and for. Okay. So in one region, there are approximately 640 trees on 12 acres. So how many trees per acre? How many trees per acre? Trees per acre. Okay, that's the rate that they want. So it's what? 640 for 12, over 12. 640 trees over 12 acres, things of that nature. And here, Latanya drove 38 miles on 6 gallons. So here, what they want is what? Miles per gallon. That's what they want. That's the rate. That's the rate or ratio. And then here, the temperature changed by 10 degrees or dropped 10 degrees Fahrenheit over 4 hours. So that's a different ways of expressing rate. Okay, unit rates. Basically, unit rates. Think of this as when you actually go. You actually just simplify the fraction. When you actually just simplify the fraction, and essentially you convert the rate into a decimal. You convert the rate into a decimal. That's a way of thinking about it. Here it's saying a rate is basically a ratio with a 1 as the denominator. But another way of thinking about it is take the ratio or take the rate and just turn it into a decimal. Simplify it, convert it from a fraction to a decimal. So I'll show you that. So to convert a ratio to a unit rate, divide the numerator by the denominator and maintain the measurement. Okay, so what does that mean? So Let me do one here. There's a lot of words on that other page, but basically, um, a tank of gas. Well, let's say it this way: a 20-gallon tank of gas will go 340 miles. Okay, what's the miles per gallon? Okay, what's the unit rate? That's the unit rate. Okay, so take the miles, 340 miles, take the number of gallons, and then so essentially what you have is you have the fraction 340 over 20 miles over gallons. Okay, so we're just kind of what I did is I just put the numbers together to make a fraction. So convert this to a decimal. And how do you convert it to a decimal? Every fraction, the way you do it is top divided by bottom, numerator divided by denominator. So 340 divided by 20, break out your calculator. So that becomes 17. 17 miles over gallons. Okay. That's what that is. That's the actual unit rate. You go 17 miles for every 1 gallon of gas. 17 miles for every one. That's the unit rate. You use the unit rate quite a lot too when you go shopping. Okay. When you go shopping. So think about a box of cereal has, let's say 20 ounces of cereal and sells for, let's say 4.99. Okay. What's the unit cost? So the way that you write the unit cost is you have to make a ratio. What's the price per quantity? Price per quantity. So if the price is $4.99 and the quantity is 20 ounces. So now convert, so turn that into a decimal. 4.99 divided by 20. So what is that? 4.99 divided by 20. So that's 0.2495. Now you got to keep the units, keep the dollars in front and keep the ounces in the bottom for 1 ounce. And by doing the division, 4.99 over 20, what we've effectively done is we've turned the denominator into 1. We divided the top and bottom by 20, so into 1. And so this would be the unit cost. So this is the price you pay. You pay 24.95 cents, if you will, for every 1 ounce of cereal. For every 1 ounce of cereal. So why do you do this? Think of going grocery shopping. Okay. Which is the better deal? Okay. Okay. So a box of diapers sells for, let's say, $15 that has 24 diapers, or a box that sells for $20 that has 30 diapers. Okay. For those of you who are parents of young kids, that we used to do this calculation all the time. So which one's better? So basically this says which has the better unit price. By saying which is the better deal, which one has the lower unit price? Which has the lower, oops, unit price is basically the one that is the better deal. So so you want to make a ratio, okay? So the ratio is going to be what? The cost, the unit price always has the cost in the top over the number of diapers, over the number of diapers. So what you're doing is you're saying you're trying to find the cost for every one diaper of one diaper. So take $15 over the 24 diapers. I'm going to put D for diapers. Or or if you're going to spend 20 $20 for 30 diapers. Okay. Convert 15 over 24 to a fraction. So and keep your units. So that's 0.625 cents for every one diaper. or 0.66 cents, 667, if you will, for every one diaper. Okay. So this is the better deal. The $15 for 24 diapers is the better deal because it has a lower unit price. Now, typically, that's not the way it works. If you go to things like Costco or Walmart, you buy in bulk, the more you spend, the more you get. Basically, the whole concept of Walmart and Sam's Club, I should say, not Walmart, Sam's Club and Costco is buying in bulk. Buying in bulk saves you money. And the reason is because it has a lower unit rate. Now, you may actually spend more in real dollars, but over time, because you're having a lower unit rate, if, you know, over time you save by buying in bulk. That's what it is. That's how that works. So unit rate means converting the fraction down to one. And basically that just means convert the ratio into a decimal, but you still want to keep your units. And unit cost, what I'm dealing here, the unit price is actually a specific kind of unit cost. It's cost per quantity. And that's basically Costco and Sam's Club. So yeah, there's unit cost is a specific type. Okay, so here we have $4.19 for 46 ounces. So, what's the unit cost? So we take the 4.19 and divide it by the 46 ounces. Okay, so turn that into a unit cost. So, and remember this is dollars in the top and ounces in the bottom. So this gives us 9 cents, so 0.091 for every 1 ounce of juice. That's how you do it. Just take the cost and divide it by the quantity. Cost divided by the quantity. And so, yeah, they're doing the same thing here. Suppose you spend 70 cents more, but get 64 ounces. What does the unit cost become? So that's comparing the cost of juice in 3 different scenarios. Which one has the better unit cost? Okay. Oops. There we go. And then finally, well, let me kind of go forward. Proportions. Proportions is the final thing I want to go over. And really, you know everything you need to know. Now we're going to put it all together. What is a proportion? How do you determine whether two ratios are proportions? And then we're going to solve a problem using proportions. So basically, proportions themselves are basically just two ratios that are set equal to each other. So two ratios or rates, two ratios that are set equal to each other. That's all it means. Okay. So here, let's take A, 5:12. So this is a ratio, 5:12 is equal, oops, 12, sorry, is equal to the other ratio, 30:72. That's what that means. A proportion is two ratios that are set equal to each other. Okay. The question though is, and one of the things you're going to have to determine is when are two ratios equal to each other? How do we determine whether two ratios are in fact a proportion? So you have to determine, are these two fractions, let's take A, 3/5, is that equal to 9/15? There's sort of two ways to do it. But the way I'm going to show you here is what we do the cross multiplication process. So because there's an equal sign here, because there's an equal sign, we can do cross multiplication. And basically it says take the numerator of one fraction and multiply with the denominator of the other fraction. And then set it equal to the other cross, the denominator of the first fraction times the numerator of the second fraction. Okay, so we have 3 times 15 and 5 times 9. Do the multiplication. So this is 45 on the left, 45 on the right. Because we get the same thing on both sides of the equal sign, that means yes, these fractions do form a proportion. They are equal to each other. That's what that means. The fractions are proportionate, meaning the two fractions are equal to each other. That's what that means. So let's apply that process then to this one, B. 8 times 5 halves. So 8 times 5 halves Is that equal to, is that a proportion with the other cross? 4 times 10. 4 times 10. Sorry. So on the right side, that gives us 40. What is 8 times 5 halves? Well, you have to remember you have to convert the 5 halves to a improper fraction of 11 over 2. 11 over 2. And then this becomes 8 over 1. So it becomes 88 over 2 equals 40. But simplify the 88 over 2, and that gives you what? 44. These are not the same. 44 is not equal to 40. So that means that no, this is not a proportion because the fractions do not end up yielding, the cross product doesn't end up yielding the same thing. So let's see another example right quick. So let's do this one right here. Do the cross, 4 times 27, and then 9 times 12. Set those equal to each other. See if it gives you the same thing. So I'll type now. 4 times 27, do that cross. Is that equal to 9 times 12? Well, 4 times 27 is what? 98? Nope, 108. Oh, calculator time. 108. And then 9 times 12 is also 108. So then, yes, it's a proportion. Yes, the ratios create a proportion. Because when you do the cross product, you get the same thing. That's how you know. And this whole cross product business is actually how what we're going to do to solve proportions. Basically, take the cross product. So we have x over 13 equals 6 over 39. So what we're essentially asking is what value does x have to be in order for it to be a proportion? What value of x does it have to be in order to be a proportion? So use that cross product process. X times 39, so that gives us 39x equals, and then do the other cross, 6 times 13. So let's do the multiplication, 39 times x. So what's 6 times 13 is 78. And then remember, now look at what you got. You have an equation, just like we had a couple weeks ago. So divide both sides by that 39, get the x by itself. So when we do that solving, we see that x equals 2. X equals 2. That's the value that x has to be in order for this thing to be a proportion. And so really the whole thing boils down to apply the cross product process. Do the cross product. That's all it is. And then here, solve the resulting equation. That's it. That's the process. So let's see another one. So here we go. What value does n have to be in order for this to be a proportion? So we do the cross product process. So 2 times 81, 2 times 81 times, and then the other cross is 9 times n, or 9n. So 2 times 81 is 162 equals 9n. And then divide both sides by the 9. Divide both sides by 9. So break out your calculator. 162 divided by 9 is 18. So n would be 18. Boom. There it is. That's all it is. Okay, so I think that's it on this one. Yeah, that's it. Okay, so I'm going to go ahead and pause here. So we looked at how to create a ratio, what's the connection between ratios and unit cost, and basically unit cost is a ratio itself. It's just that you convert the ratio, the fraction, into a decimal to see the quantity per 1 unit, and then you can take two ratios and set them equal to each other to create a proportion, and then use the cross product process to help you solve problems. So hope you found this helpful. Let me know if you have any questions as you work through everything, and I'd be glad to lend a hand this week. Hope you have a great day. Bye.